This is a short presentation about voice communication for space mission control. What is the content of the presentation? First of all, we will talk a little bit about the German Space Operations Center. Then we will talk about voice communication systems for mission control, what makes them special, how are they used. And the last part is to talk a bit about future developments we do with our openvocs project. This is a picture of the main control room for multi-mission of the German Space Operations Center. You can see every position is manned and everyone has a headset. They talk about every topic they have with the communication system. There are several other control rooms, for example, for engineering or other kinds of support, which are not located within the German Space Operations Center, which are connected via the voice communication system. So what are voice communication systems for mission control? We will use Columbus as an example. Columbus is part of the International Space Station, a multinational corporation. Here you see a picture about ISS operations and management. You can see a lot of different control centers which are all connected, and everyone needs to talk to each other to coordinate for missions at the International Space Station, or to coordinate some ground activities, or to coordinate experiments on board of the station. We will talk about the European part, Columbus. The setup is a hub-based setup, where the call CC in Munich acts as a hub for all European sites. So everyone in Europe is connected to Munich, and Munich connects to Moscow, to Huntsville, and Houston. How is the user interface of the voice communication system? Here you can see a picture about the voice communication system, which is at the left of the console, and the woman is touching the screen to select some loops. She's wearing a headset and a push-to-talk button. The user interface pretty much looks like this. We have a selection of voice loops, and the user selects the voice loops for talk or monitor. Monitor is shown in blue, talk is shown in green. Let's talk about the system overview for voice communication systems. First of all, we need an audio output. We need an audio input. We need a push-to-talk capability. And we need to select the channels. Channels are a special use case. Voice communication systems use multi-party multi-conferencing, which means one participant is active in several conferences at the same time. You can imagine this as having opened several Skype calls in parallel. The next specialty is the use case with the participation states. We have listen-only capabilities, so you are just allowed to monitor a voice loop. We have talk-enabled participation state, which means you have selected the loop to talk, and we have actual talking. This is done when push-to-talk is pressed. The next specialty is a role-based access control mechanism. Access permission management is done with user roles. So a user is assigned to a role, and the role has some access rights within a voice loop. These are, as mentioned earlier, monitoring only or monitor and talk. Each role has a different layout. This is shown with this picture. So the flight director has a specific layout, the flight controller has a specific layout, the ground controller has another layout, and the power systems engineer has its own layout. You see the participation states here with the microphone and headset for talk enabled and headset only for monitor enabled. Permission management and multi-party multi-conferencing makes the system special. Vox systems are coordinated within a dedicated worldwide network with an own WAN, LAN, IT infrastructure, and user terminals. For Vox systems, the systems engineer must have capabilities for user support to support the user interfaces or user management databases. We have IT support in terms of software and hardware management. We have network support for IP-based communication or TDM-based communication, down to bit-level support of framing and signaling. And of course, we have audio technology with hardware, microphones, loudspeaker, and the software for summation and distribution, and codecs. How is the path to talk to the space station? As mentioned earlier, all European communication is centralized within the node in Call CC in Munich. So if you press push to talk on a space to ground loop, your voice is transmitted to Houston or Huntsville, depending on the loop. Then it's connected with White Sands. White Sands uplinks the voice to a TDIS, tracking and data relay satellite, which is a geostationary satellite. And the geostationary satellite is transmitting the voice down to the space station. The network of geostationary satellites is used to have a better coverage than by ground networks. So what are future developments for voice communication systems? What are we doing? Up to now, we have 50 years of user interface mapping. You can see the voice communication system here in the right part of the screen. We have a lot of buttons, and some buttons are selected and some buttons are not selected. These are actually knobs, so hardware buttons integrated within the console. The user interface today evolved to some touchscreen interfaces. This is shown for ESOC, QualCC, and the Galileo Control Center as the biggest operation centers in Europe. They all use dedicated touchscreen devices to select the voice loops. The common setup is to use a professional headset, a wireless push-to-talk unit, and an embedded PC with industrial touchscreens. For the industrial touchscreens, we already have identified a conditioning issue. Users are used to use capacitive multi-touch devices now. And the industrial touchscreen is resistive and has just the one-touch capability. So a new user who is not used to the industrial touchscreen has the conditioning issue with the consumer devices we use today. What is our idea? Our first idea is to continue with user interface mapping. There was a transition from hardware buttons to software buttons which makes the buttons or the system configuration easy to exchange. We want to make the hardware easy to exchange. So we transition to software buttons on non-dedicated hardware. This is the idea for the user interface, a software-based solution. We have created a prototype with HTML5 and WebRTC. WebRTC is used in a lot of different browsers. We can see the touchscreen interface, which is shown as an HTML page, and a device, which is a tablet here. We have done some research for multi-touch interactions, for example, to change the volume, to release loops, to enable talk, or to open some playback. With our WebRTC-based voice interface, which just requires an actual up-to-date browser, we can use any device as a voice terminal. This can be a tablet, a convertible, or a smartwatch. So every device has advantages and disadvantages. We have also done some research on push-to-talk and tried to implement a different implementation. So the current analog implementation is that you have a push-to-talk button directly connected to the cable which transmits the audio. If you use a smartwatch, for example, we can use the interface from the smartwatch to simulate the push-to-talk button. So you press on the smartwatch instead of the push-to-talk button itself. This allows to use different kinds of headsets. So consumer-grade headsets instead of dedicated mission control room headsets. Our openvocs implementation is using a web browser which delivers the client. It's based on WebRTC for media exchange and uses HTML5 to show the user interface. We have implemented a dedicated secure media gateway implementation. What about full mobility? If we enable smartwatches to be able to connect to the system, we can imagine scenarios which are now not possible, because you can move away from the console and still use Vox. This may enhance operations or may open up new capabilities for operations. Meanwhile, at the ISCS, they experiment with smartwatches too. So in 2015 there was a contest for app design for smartwatches, which can be used on the ISS for different kinds of operations. What we have with openvocs is a system evolution. So we have the state-of-the-art control UI, which is independent of the operating system due to the use of HTML5 and WebRTC. We also have a system revolution, because we can enable full mobility with smartwatches. What we do is we resync Vox. Thanks for listening. Goodbye.